Okay, this video is going to take you through chapters 2 and 3 for the review for the midterm. So again, you want to take notes on these and then submit them for the classwork grade at the end. Start with chapter 2, and we start with 2.1. So chapter 2 is your conditional statements. In chapter 2, section 1, you got introduced into what a conjecture is. And this is a statement that's believed to be true based on reason. Asked for the definition here, but what you will be asked for is like a conjecture that's true. So you might get a choice that says, identify which conjecture is true. Multiples of 2 are always even, which would be true. Or 2 angles that are linear pair are always supplementary, that would be true. 2 angles that are linear pair are congruent, that would be something that's not true. So you just be identifying a statement, again, that's true based on reason. And then in 2.2, you started to identify a conditional statement. Which is one that can be written in if-then form. And again, you can get like something, which of the statements is true. If 2 angles are supplementary, then they add up to 180 degrees, which would be true. If 2 angles are complementary, they add up to 180 degrees, that would be false. And then based on the conditional statement, you learned an inverse, a converse, a contrapositive. So if we started with the statement, if you study, then you'll get an A. So if we asked if that was true, that's not necessarily true. And if it asks for a counterexample, which is something that makes that statement false. So something that makes the first part true but the second part false. That could be like you did study but you still didn't get an A. Okay, that would be a counterexample. The inverse is changing each part of it to the not version. So if you don't study, then you won't get an A. Which also might not be true. Maybe you're super smart, you don't need to study. That's the inverse. The converse is the switching of the order of the statement. So the if becomes the then, and the then becomes the if, or the hypothesis becomes the conclusion becomes the hypothesis. So if you got an A, then you studied. Okay, again, not necessarily true, but that is the converse. And then the contrapositive is switching and negating. So if you didn't get an A, then you didn't study. So the second one was the converse. where you switch the order. And the last one is the contrapositive, where you switch it and change it. So if you think about the fact that contrapositive is the longest word out of those, that's the one that you do the most work. You have to switch it and you have to change it. You also started your algebraic and geometric proofs in this chapter. So that was 2.5. 2.5, you learned all the properties. So again, this is just a snapshot from your book from 2.5, but you had the addition property of equality, which said you add the same thing to both sides, it keeps your equation balanced. Subtraction property, which means you subtract the same thing from both sides. Multiplication, you multiply the same thing on both sides. Division, divide the same thing on both sides. Reflexive, if you think about reflexive, is anything that equals itself. Symmetric would be the reverse of the order. So if A equals B, then B equals A. Transitive is the one with the middleman. So if A equals B and B equals C, B is what's linking those two statements together. So you can remove B and link A to C. And then the substitution, if A equals B, then B can be substituted for A in any expression. So if you saw if A equals B and 2A equals 10, then 2B equals 10, B just got substituted in place of the A. That would be substitution. So the good news here is you don't have any proofs. You do just need to identify properties. So if it gave you a statement or it asked you to identify what would prove it, then that would be, you would be just identifying your property. And that's like something like 25 and 26 from your packet. Or sorry, 26 and 27. This is just a snapshot, again, from 2.5, but this is now those three properties applying to segments and angles. So reflexive, symmetric, and transitive also apply to angles and segments. A segment that's equal to itself would be reflexive. An angle equal to itself would be reflexive. And then if you reverse the order, it would be symmetric. So if 1 equals 2, then angle 2 equals angle 1. That's symmetric. And then transitive is, again, if I have three things that are linked by one middle person or middle segment. So if PQ equals RS and RS equals TU, then PQ equals TU. That would be your transitive property. Again, these are all of congruence. The first ones were all equality. So for chapter 2, section 2.1, are questions number 23, 44, 45, and 46 from your packet. 2.2 can be found number 24 and 25. And 2.5 are numbers 26 and 27. I'm gonna continue the video to cover chapter 3 as well. So chapter 3 was where we switched actually teachers, and I came in and we started talking about parallel and perpendicular and all that good stuff. So 3.1 was parallel, skew, and intersecting. So you would have identified a pair of parallel segments or perpendicular segments or skew segments. So you'll see something like number 28 in your packet where you got given a box and it would say identify the parallel. You could either see parallel segments or parallel sides, planes. So the segments could be something like these front two, right two, coplanar segments that don't intersect. And then you had skew, which was non-coplanar. But they also don't intersect. So something like the front corner of this box and then the back corner running vertically and horizontal, those would be non-coplanar and they never intersect. And then parallel planes, which are just planes that don't intersect. So the top of the box and the bottom of the box could be planes or parallel planes. And we name planes by 3 or more lines that lie on that. 3 or more points that lie on that plane. In 3.2, we started talking about all the special angles that were formed by 2 lines and a transversal. So we just had 2 lines. They weren't necessarily parallel yet. And then we had the transversal, which is the line that intersects 2 or more lines at different points. And then we were able to identify, so there's 5, 6, 7, 8. There's 8 angles that are formed by this type of relationship. And there were 4 special angles corresponding. Alternate interior. Alternate exterior. And same side interior. Which some books call consecutive interior as well, same thing. So the corresponding is if you make that little box around your angles, then the corresponding angles lie in the same corner of that box. So top left and top left would be angles 1 and 5. That would be a corresponding pair. Top right and top right would be angle 2 and angle 6. Bottom left and bottom left, angle 3 and angle 7, and the bottom right and bottom right, angle 4 and angle 8. Alternate interior were in between the two lines, but on all opposite sides of it. So 3 and 6 are alternate interior. And then 4 and 5 are the other alternate interior pair. Alternate exterior lies outside the 2 lines, but again, opposite sides of the transversal. So 1 and 8 are your first pair of alternate exterior. And then 2 and 7 were the other pair. And then the last one is same side interior, and same side interior is exactly that. Same side of line interior, which is in between the 2 lines. So angle 3 and angle 5 are same side interior, and angle 4 and angle 6. So actually we knew what these were in 3.1. This 3.1 is where they identified the actual type. And then in 3.2 is when we identified what happens if those lines are parallel. So 3.2 was the angles formed by parallel lines. So now I'm dealing with all parallel lines and the angles formed by them. So this time my lines are parallel. They'll either be stated as parallel or you'll see the little arrow marks on them. So something like that would show that they're parallel. And the relationships we identified, and they were all theorems and they all started the same way. If 2 parallel lines are cut by a transversal, and then we learned a bunch of stuff about the angle relationships. So the first one was that corresponding angles are congruent. Then we learned alternate interior angles are congruent. We learned alternate exterior angles are congruent. And the different one was same side interior. And same side interior angles were supplementary or add to 180. So you'll start to see stuff in like question number 30 where they tell you that they're parallel and what kind of angle relationship you can identify based on them. So if they're corresponding, you know they would be equal. If they're alternate interior, they would be equal. Alternate exterior equal, and then same side interior would be supplementary. And then in 3.3, we reversed it and we said what angle relationships would make the lines parallel. So we started if corresponding are congruent, if alternate interior are congruent, if alternate exterior are congruent, or if same side interior are supplementary, then the lines are parallel. So you'll see this once in your packet on number 36, like it says what value of x would make the lines parallel. And so you're just looking to identify, in that case, if they're corresponding, then those two angles would have to be congruent. If they're alternate interior, they'd have to be congruent. Alternate exterior would have to be congruent. And the same side interior would have to be supplementary. In 3.5, we started talking about slopes of lines. So we start talking about what is slope. Slope is your rise over your run. It's your vertical change over your horizontal change. And the equation is y2 minus y1 over x2 minus x1. So you're going to see a couple of different kinds of questions here. You are going to see some where you have to like identify the slope from a line. So you just be counting rise over run. Or you're going to eventually be finding the equations of a line. So if you were given a graph on a coordinate plane of a graphed line, you can actually choose if you want to just count your rise over your run, or if you want to use the slope formula. So if I had a coordinate plane and I had a point like here, and then my line running through it, and it asks you to find the slope of this line, you can either count your rise from one to the other, so you can either move up and left or down and right. If you do that, you're going down, which is a -1, that's your rise, over 1, 2, 3, 4, that's your run. That would be your slope. Or you can identify these points, so this is 4, 1, and this is 0, 2, and use those to plug them into the equation, which is y2 minus y1 over x2 minus x1. And it doesn't matter which ones you choose to be your x1s or your y1s, as long as within each set they are the same number. So I can do 1 minus 2 over 4 minus 0, and I'd get -1 over 4. So same answer. We also talked about what the types of slope in this section. So if you were to get a question on positive, negative, or undefined, or vertical, you would just need to know that if the line is a vertical line, then it has undefined slope or no slope. If it's a horizontal line, then my slope is 0. And then if it is rising as I move to the right, that would be positive slope. And if it is falling as you move to the right, then it's negative slope. And then in the next section, we got deeper into finding the equations of lines. So in 3.6, we got into finding the equations of lines. And again, this is just a snapshot from your book real fast. We learned 2 different types of equations, the point slope form of a line, and the slope intercept form of a line. So the point slope is y minus y1 equals m times x minus x1, where the x1, y1 is the point and the m is the slope. And then we learn the slope-intercept form, which is the one probably most commonly identifiable, which is y equals mx plus b, where m is the slope and b is the y-intercept. And then we had two special cases where it was an x and no y, that's a vertical line, and a y and no x, that's a horizontal line. So the types of questions you'll see in this section are either going to be find the equation of a line or graph. So I'll show you an example, a quick example of both of those. So if it said write the equation with slope, let's say -3, and point to -3, actually make that -8 so it's different, and put it in point slope format. So I know I'm using point slope, which is y minus y1 equals m times x minus x1, and the m is your slope, and the 2 would be my x1, and the -8 would be my y1. So y minus a -8 would equal -3 times x minus 2. And then the only thing you need to simplify is the -8. So that would be y plus 8 equals -3x minus 2. And then you leave it just like that. So in point slope form, it gets left like that. If it asks for it in slope intercept, I would distribute it. The next part would be kind of like the reverse of that. If it said to graph or to, graph the line that was in that format. So if it said to graph this equation, I would know from it that my slope was -3 because that's what's in front of the parentheses. And the point is the opposite of what follows the x, so I would make that a 2. The opposite of what follows the y, which is a -8. And then I would graph my point. So I'd go to the right 2 and down 1, 2, 3, 4, 5, 6, 7, 8 and plot a point. And then I would use my slope, which is in this case -3. And that -3 would be over 1. So my rise is -3, 1, 2, 3, and my run is 1. And then I would just connect my points to make my line. Also in 3.6 was parallel and perpendicular lines. So we learned that parallel lines have the same slope. And perpendicular lines have slopes that are opposite reciprocals. So if it said to find the slope of a line that is parallel to a given line, then the slope would be the same. So if it said, if I took that last example, y plus 8 equals -3x minus 2, I think that's what it was, and said what's the slope of a line that's parallel to this, because the slope of this line is -3. The slope of a line that's parallel would also be -3. And the slope of a line that's perpendicular, I would change the sign, so it goes from negative to positive, and make the reciprocal. So 3 over 1 would become 1 over 3. It asks you to identify from an equation if lines were parallel, intersecting, or coinciding. So parallel would be if they had the same slope, but a different y-intercept, or a different b. Intersecting would be the same slope. Intersecting would be a different slope. because as long as they weren't the same slope, they would eventually intersect. And coinciding would be the same slope and the same y-intercept. So they end up being the same line. They would overlap. So you would just get two equations and you would get them in the same format and then identify if they have the same slope but a different y-intercept, if they have totally different slopes, or if they have the same slope and the same y-intercept. Okay, so that is all the information for chapter 2 and chapter 3. So for chapter 3, the problems that you can do from 3.1 would be number 28 and 29. From 3.2, number 30. From 3.3, number 36. 3.5, number 14. And 3.6, numbers 15, 16, 17, and 21. And then again, make sure, so you can submit your notes now and use the rest of the time to work on those problems, but make sure you submit your notes before you leave so that you can earn credit for the classwork assignment. Have a great day.